Hello, Prealgebra students. This is lesson 65. Our objective is how do you use similar triangles to find measures? And this is really a good application of math in real life if you're trying to find the height of things. So let's just go ahead and go through a couple examples and you'll see how this works as we go through them. The first one says, this guy wants to know the height of a flagpole. She stands a meter stick in a vertical position and finds the length of its shadow is 120 centimeters. At the same time, the shadow of the flagpole is 30 meters long. How tall is a flagpole? So what we need to realize is that we are creating two similar triangles. The first one is the larger one, the flagpole, and the other one is the meter stick that she stands up. The meter stick is 100 centimeters and 120 centimeter shadow. This one is a 30 meter shadow, and we're looking for this one. In fact, I'll just call that length X, or if you want to call it H or something like that. These are both right angles, and since it says at the same time of day, we know that this angle is the same as this one because at the same time of day, the sun rays come down parallel to each other. So then we know that these two are similar to each other. Since these two triangles are similar, we can set up a proportion. We can say the height over the length is equal to the height over the length. So the height, I'll say X, over the length, which is 30, is equal to the height over the length. So now we can use our butterfly method. This times this is 120x is equal to this times this. It's equal to 3,000. To get that x, those x's and the 120 is multiplying, so the opposite is to divide by 120. This part over here on the left becomes just 1, because 120 divided by 120 is just 1. 1 times x is x. Then we take 3,000 divided by 120, put it on the calculator just to save some time, and that is 25. So then my height is 25 meters. Also, just logically speaking, since this shadow is longer than the height of this, it would make sense that this shadow would be longer than the height of this. So it kind of does make sense that this is shorter than its shadow length at that time of day. What we just did to find the height of that flagpole is what we call indirect measure. Indirect measure is whenever you use something other than directly measuring it. It's like whenever you back up to a wall and you put a mark there and you use a measuring tape along the wall. That's what we call direct measure. But like a flagpole, it's pretty hard to shimmy up the top of it and take a measuring tape that's 25 meters long. So that's what we call indirect measure. It's when we use like a triangle to solve that proportion. Let's do one more example here. It says Josh stood facing a pond. From his viewpoint, he could see 2 points on opposite sides of the pond. P1 down here and P2 up here. He wanted to know the distance between P1 and P2, or really he wants to know the length across this pond. But he did not have a way to measure the distance directly, so he didn't really feel like getting in and swimming across there with a measuring tape. Josh had an idea. He could indirectly measure the distance. He marked his position with a large stone right here. Put that red dot. Walked 10 yards towards P1. So from here to here is 10 yards. And drove a stake in the ground. He tied a string around the bottom of the stake and stretched it out in a line parallel to the line from there to there, from P1 to P2. So this line and this line are parallel. Josh then returned to his starting position and walked in a straight line towards P2. So he came back here and is walking this way now. When Josh reached the string, he drove another stake into the ground and tied off the string. Josh knew that the distance from his starting position to P1, so this length along here, is 45 yards. So this length right here is 45 yards. If the starting distance, the distance between the starting first stake and the second stake is 8 yards, so this length here is 8. How far is it from P1 to P2? So let's draw those two triangles. Here's the first smaller one between the two stakes and his rock. This is 10 yards and 8 yards. Then we have that big one that goes from that rock to P1 to P2. The whole length here on the bottom is 45 yards. And we're looking for this one. I'm just going to call it D, the distance across the pond. So we're going to do something similar. The height over the length is going to equal to the height over the length. So I'm going to say 8 over 10 is equal to D over 45. Multiplying 8 times 45, I get 360. 10 times D, I get 10D. These ones are multiplying, so the opposite is to divide. So I get that distance is equal to 36 yards. So the distance between P1 and P2, or the length across that pond, is 36 yards. Alright, that brings us to our homework. It's on page 443. You're going to do all the practice set and then 6 more of your choice. Good luck.